Now let's look at whether the graph is above or below the x-axis. Some of this information you get by looking at the tail. So for example, for A, notice how I have 1, 2, 3 x's. So this is an odd graph. The lead term will be minus 2 times x cubed. Odd function, well, an odd highest power with a negative in front. That means that I expect it to start high and end low. For right now, I'm just going to mark that it starts above the axis and it ends below the axis. Now what happens at my intercepts? I've put an intercept at -1, 0 because of this term, at 2, 0 because of this term, and at 4, 0 because of this term. I also put in 0 minus 16. Now, I don't bother keeping the tick marks at the same scale for the x and the y-axis because 0 minus 16 would appear so far down the graph. So I'm going to use the tick marks for the x-axis. I'm going to be careful to label for the y-intercept though. What is happening as it comes towards the value of -1? It's starting positive. At -1 it's going to be 0. In between -1 and +2, I expect the sign to stay the same. The sign is only going to change for polynomial functions at an intercept. Now, notice already that my y-intercept is between -1 and +2 as far as its x value is concerned. And notice how it's below. If I have a single root, the x plus 1 is going to be a single root, then I expect the sign to change. So it starts positive. I expect it will turn negative. At a +2, since that's a single root, I expect the sign to change again. Let's look at what would happen if we plugged in 1 or if we plugged in 3. If we plugged in 1, we would have a negative, a positive, a negative, a negative. That makes 3 negatives, so I expect it to be negative when x is 1. But if I plug in 3, it would be negative, positive. This term would switch to being positive and negative. So 2 negatives, the first and the last term, would make a positive when x is 3. So I expect it to be above the graph here, go through, touch this point, rise up, go above the graph, fall, and finish below the graph. If you do the same procedure on B, first note what the highest power would be. For x, 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 it should be 4 times x to the 4th. That's an even highest power, a positive leading coefficient, so I expect it to be cupped up to start high and to end high. So I'm going to mark positives here and positives here. It's starting above, it's touching, and then when it finishes, it's finishing high. That's the behavior of the tails. Now look at each of these roots. At -3, this term is 0. When I pass -3 going from left to right, this term will change from being negative to being positive. Changing a single sign will change the whole thing from positive to negative or negative to positive. Here, since it starts out positive, it should turn negative. When I pass through -1, this term is a single root, So I expect the sign to change again, in this case from negative to positive. That's a good thing because on the previous video we found that the y-intercept was to be the point 0, 96. And now I'm especially glad that I don't have to mark all the way up to 96. I just note where the position is. As I pass through 2, that goes with this root, I expect it to change sign again because this is a single root. It's going to change from positive to negative. When it passes through 4, again this is a single root, so I expect the sign to change from negative to positive, which is a good thing because I already identified that this should end up high. Start high, end high, and notice how the y-intercept also had to be high. For C, here I've put in a second order. So if I'm looking at powers of x, I would have x times x times x. This would be an x squared. So my lead term will look like an x to the 5th. As for the y-intercept, this is a case where it goes through the x-axis. If x is 0, then the lead term is 0, which makes the whole thing 0. So this polynomial function will go through the origin. It also goes through negative 3, 0, positive 3, 0, and 1, 0. Fifth order, the lead coefficient you should think of as a positive 1. So I expect this to start low and end high. So start negative and end positive. As I go through a negative 3, this term will change from being negative to being positive. That's a single change, so it should change the entire function from being negative to being positive. Next, it hits the origin. This term now changes from being negative to positive as we move from left to right. That will change the entire function from being positive to negative in this zone. If you ever have any questions, you can try plugging in a number. Between 0 and 1 would be 1/2. If I plugged in 1/2, I'd have 1/2 times a positive number times a negative number times something which was squared, which was always positive. So positive times negative times positive is a negative number. Now, as I hit this point, as I hit x equals 1, and I move over to x equals 2, the sign is not going to change because this is a second order term. I expect the sign of the entire function to stay the same, to stay negative. Suppose I put in a number like 2. I'd have positive times negative times something squared, which is always positive. Again, the character of this is that it's always positive, except of course when x is 1, in which case it's 0. So in this zone, it should stay negative. So it starts below, it rises above, it goes below, it has to rise up and touch, but then it's going to go back below and finish by rising.